At some point in almost every developer's life, they write some Python code. And while Python is a great language, it leaves a lot of traps that are very easy to fall into if you don't understand some of the nuances and more of the detailed features. That's why in this video, I'm going to cover the 7 Python anti-patterns that I see used all of the time. I'll show you a ton of code snippets that look fine, but in reality can lead to some pretty negative consequences, especially if you don't know what you're doing. With that said, let's get into it with the first pattern. Now, the first pattern on my list here is multifaceted, and it has to do with not understanding the time complexity of the fancy syntax that Python provides. Now, a lot of times in Python, you'll see people do things like this, right? Where they, for example, concatenate 2 lists together, or they concatenate a string together, or they use a method like .find, right? Or .count, or something along those lines. Now, while all of these tools are really useful and they make the language a lot simpler and easier to understand, they have some hidden consequences that a lot of developers don't understand that has to do with the time complexity or the performance of those operations. So I'll zoom in here and show you a few examples of when that occurs. Now, I'm not going to get too technical, but when I talk about time complexity, I'm talking about something like Big O notation, where we're roughly trying to compare various pieces of code based on the approximate number of operations that they would perform in what's called a worst case. Don't worry too much if you don't understand what that means, but I'll kind of break it down for you. So let's look at this example right here where we're building a list. Now, some people think that just because this syntax exists, it means they can kind of use it whenever they want. So what they might do if they want to make a list of numbers, say, 1 to n, is they'll do something like this. They'll say, okay, result is an empty list. We'll loop through a bunch of numbers, and we'll just add the next value as a list to the result. Now, while this will work and we will get a list that contains all of the numbers, this is going to be a significantly worse performance operation than if we simply used the built-in append method in Python. Now, the reason for that is that whenever you do this operation, it's going to actually create a brand new list. So for example, if we have 1 and we're adding 2 to it, this actually means we have to create a brand new list. We're not just adding one of the elements to the other list, which is going to cost us 2 operations. Now, same thing happens when this list gets larger and larger and larger, right? And we add something like 6 to it. This no longer just takes 1 operation to complete, where we're adding 6 to the end of this list. We need to make a brand new list that contains all of the values, which means we have to use all the values from the first list and add them to the second list and then make a new list. The point is, this will turn this operation from what should be an O of n time complexity operation to an O of n squared time complexity operation, which is exponentially worse. Now, same thing happens when you're working with strings. If you concatenate strings together, you need to create a brand new string, which results in a much worse time complexity operation. And then similar situations occur with some of the methods that you see here. So I'm going to go over them quickly, but for example, if we actually use this syntax where we check if an item is not in or is in some type of result, this is going to result in an O(n) time complexity operation, which we could be mistakenly doing a bunch of times. In this situation, it would be better to first convert this into a set. So say result is equal to the set of results or something like that, so that we're able to actually check if an item exists inside of that set in a better time complexity operation. Same thing coming down here if we're checking the membership, okay, same thing with the nested list. I'm not going to go over all of them. The point is, just because Python has this syntax doesn't mean you have to use it. So to show you a few good examples here, this is a way that we would build a list using an append method, which is much more efficient. Here's actually an even better way that we can make a list, although it's not super important. Here's a way that we could combine words together by using the .join method rather than concatenating a bunch of strings. Here's an example of using a set to remove the duplicates, and you get the idea, okay? I'm not going to go through all of the code. The point is that you want to understand what the time complexity of the operations are that you're using, so you don't accidentally use something that's really inefficient. So we're going to dive into the next pattern now, but I do just want to quickly disclose that I have been using AI to generate this code. And while AI is great, when you have a lot of tools and you have them all open at once and they're not talking to each other, that can be a bit of a nightmare. Now that's where Aria, today's sponsor, comes in. Aria is an AI orchestration platform where you can build, manage, and run AI agents in a single place. You can connect any model, whether it's OpenAI, Anthropic, or Gemini, and link your data from things like Notion, Slack, or Google Sheets, and actually have agents that do end-to-end work. There's no more juggling tabs or stitching APIs together. It's all unified inside of Aria. And the best part is you don't even need to start from scratch. The area community has built over 2,500 agents that you can grab instantly. Now, I actually found one there called the Language Learning Companion. And since I've been learning Indonesian recently because my girlfriend's from there, it's been perfect. I can literally ask it to quiz me on new vocabulary or explain tricky sentences, and it handles everything automatically. Now, if you want to try it out, head to the link in the description for a free trial or browse the area community and see what kind of agents you can put to work. All right, so diving back into this pattern here, a very common mistake that beginners typically make in Python is they use the double equal sign when they should actually use the is operator. So there's two operators in Python, right? Is and double equals. Now, they check different things. The double equal sign here checks for equality, but the way it checks for equality is by calling the underlying __equal __equal method on whatever objects are being compared. Now, that's fine in most situations, but sometimes you don't want to do that, especially if you're trying to look for something like a none type. If that's the case, you want to use the is operator where you actually check if something is the exact same object. I'm going to show you why in a second. Let's look at it. All right, so I'm going to show you some code that most of you are going to think is completely fine, and in 99% of situations it is, but it can lead to some negative consequences. So for example, if you want to check if a value is none or is equal to none, you really should use the is operator rather than using the double equal sign. That's because you want to check if the value is not defined or equal to the none type in Python, but by doing this equivalence, you're actually going to call the underlying __equal method, which could be implemented to return something else. I'll show you an example of that in a second, but just typically if you're checking for a none comparison, you want to use is. Now, you should actually do the same thing when you're checking for true and for false. You should say like flag is false, flag is true. You get the idea. And again, that's for the same reason I mentioned before. Now, same thing here when we look at this, we have a not equal to none. You can simply say is not none, and that is the more Pythonic way that is more accurate. Now, there's a few other examples we have here where we're comparing to, for example, an empty list, or we're comparing to an empty text string. Now, while these are not as bad, they can have some negative consequences that you don't intend, and I'll show you in a second. Now, if we scroll down here, you can see some of the fixes. So we've changed this to is none, right? Is true, is false. We have if the flag. So rather than using even like is true, it's actually better if you just say if and then directly get the Boolean value from here, right? Same thing here, we have is not none, and here we say if not items, if not text. This is a more Pythonic way that's better, where we're not going to be actually comparing against a different object, we're just checking if the thing exists or if it doesn't. Now, you can have a quick look at this code sample if you want to see the difference between a double equal sign comparison and an is comparison, but the main reason why we want to avoid this is because we end up calling this __equal method, which can be overridden by your custom classes, which could actually allow a comparison to return true when you don't want it to. I don't want to get into too much depth here, but the point is when you use the double equal sign, you're checking for equivalence. Typically, when you want to compare a value, if you want to check if something is none or if something doesn't exist, it's better for many different reasons to use this is operator or the is not operator, as you saw. Now, the next anti-pattern on my list is one that I wasn't aware of for a long time, but this is actually not using list comprehensions. Now, in Python, we have this fancy syntax called a list comprehension, which I'll show you in 1 second, and you should use it whenever possible, assuming it doesn't make the code too confusing to read. The reason for that is a list comprehension or a dictionary comprehension or a generator expression. A lot of these things that are built into Python actually have significantly better performance than using a standard for loop. A lot of people don't know that, but it is actually true. In most situations, using a comprehension will give you better performance, so you should use it when possible. I'm going to show you what I mean. Bear with me. So have a look. We have a function here where we just generate the squares of numbers. Totally fine. There's nothing wrong with this code, but it could be more efficient by replacing it with a comprehension. Same thing, we're doing a filter, right? We're looking for all of the even numbers, for example. We're creating a dictionary manually where we're adding all of these keys associated with some values, right? We have this nested loop where we're creating kind of a matrix structure. Again, all of this stuff is fine. No one's going to, revoke your PR because you submitted this. But if you want better performance and to be more Pythonic, then you really should use the approach you see here, which is using list comprehensions. A lot of people will debate with me in the comments on this, but it does have better performance, especially when you're working with a large amount of values. So here's an example of a list comprehension where we're saying we're going to populate the list with the square of a number for num in numbers. With the list comprehensions, you can add some filters as well. So we can have an if statement like this. We can do the same thing with dictionaries. We can do the same thing with sets. You see that we can actually have a nested list comprehension like this. So item for row and matrix for item and row. We can do a transformation inside of something like a set, right? So we have item for item and items if the item is greater than 0. And we can do a much more complex transformation here where we have nested comprehensions kind of inside of their own comprehension, where I have a list comprehension inside of a dictionary comprehension. Now, some may argue this is difficult to read, and in situations like that, it's okay not to use them, but typically you're going to get better performance when you do. Now, same thing, this is what's referred to as a generator expression. Not going to dive into that too much, but if you know what a generator is, you can do this. And then same thing here where we're doing these kind of conditionals, positive if an item is greater than 0, otherwise this for item in items. There's a lot of use cases of comprehensions, and if you're going to write code in Python, you definitely should prefer to use them. The next pattern on my list is a super famous one, so I'm going to go over it relatively quickly, and this is not using context managers. Now, a context manager is an object in Python that will automatically handle an enter and an exit. That means that you can kind of use a context manager, and when you're finished using the context manager, it will automatically clean itself up, so you don't have to worry about doing that yourself. There's a lot of advantages to that I want to show you here. So for example, this is something you should not do, which is opening a file manually without using a context manager. If you don't know what one is, that doesn't make sense right now, but you will see in 1 second, where we essentially open the file, we read it, and then we need to manually close the file. Now, if for some reason some error occurs before this close, the file will not automatically be closed for us, and that could lead to a memory leak and potential issues with the file where it could get corrupted. Okay, same thing when we're writing to a file. You can see we open it manually, we write to it, and then we close it. Yes, in this situation, it will be fine, but if something were to happen before the close, that could be problematic. Now, here's an example of reading multiple files. You can see we have kind of this nested try except block going on where we're reading, file 1, then file 2, and trying to add the contents together. Again, it's okay, but this is pretty messy. And if something goes wrong, we can't guarantee the file will be closed unless we use the context manager. So let's move down here to an example of what you should be doing. The with syntax is how you invoke a context manager. So I can say with, and then open file name. In this case, the mode is R as file. Now I have a kind of reference to this context manager. So I'm able to use this file object. So I can say content is equal to file.read. And then when I'm outside of this with statement, so I break out of the indentation, it will automatically close the file for me. Even if an error were to occur in here and we were to raise an exception or something, it will still be fine. Because we have the context manager, it will automatically clean up any of the operations that are defined in what's called the exit method, which I will show you in a second. Same thing, writing to a file, and you can also open multiple files or deal with multiple context managers at the same time, as we're doing right here by separating them with a comma. Now, I just want to quickly show you kind of the internals of what happens here. When you use this with syntax, what will happen for each of your context managers, so when we do this kind of open function right here, is we will call this enter method. This enter method will return something. In this case, it's a handle to the file. And then there's this exit method, which will automatically be called when this context manager is finished. So whether an exception occurred or whether we cleanly kind of exited out of this block. So these are the internal methods. You can write your own context manager as is seen here, or you can use the built-in ones in Python. But if one exists, you should use it rather than manually handling, for example, a file yourself. Now here's an example of using your own custom context manager. We say with the database connection as DB, then we can query the database, we can return some result, and automatically this exit and enter method will be called appropriately as needed. Next on my list, we have a very common anti-pattern, which is using the print statement rather than using logging. And I know all of us, including myself, are guilty of doing this, but if you're writing production Python code, you really should prefer to use the logging module. Now I'm just going to quickly show you a few things. Of course, we can print a bunch of stuff out. Totally fine, right? We can print with an exception. We can print within a try. We can print some logging information. We can print out the date or something along those lines. We can debug some values. Again, no problem. A lot of people do this and you'll be able to see the result. The issue is you're not going to know what file it's coming from, what time it's happening at, or what level of log it is, whether it's a debug, whether it's an info, whether it's a warning, whether it's an error, etc. Right? Now you could manually write that into the print statement, but it's not very efficient. And you also have no way here of very easily saving this to something like a file so you could review it later. So the good way to do this is to set up a logger. Now, fortunately, the logging module in Python is very easy to set up. I have a full tutorial, which I will put on screen here in case you want to check it out, where you can create a logger. You can set the level that you want the logger to be at, which means kind of the minimum level it will log out for you. You can change the format of the logs. You're able to see, for example, the time, the name of the file or the name of the logger, the level name, and then the message or messages. You're able to then create the logger. In this case, you can give the logger a name. The name we're using is the name of the file. That's what the _ name means. From here, we can simply log something by logging with info, logging with debug. We can log with an error. And now if we look at the logs, we're able to see much more clearly what's actually happening. And I'll show you an example of that in a second. Same thing here, a few more examples of using the logger, debugging some information, having this, kind of data logger going on right here. And I'll just show you if I call this function, you'll see that we actually set this up to log to a file. So let me bring this up here. I'm going to say Python, and then this is logging. And you'll see that we get these logs, which are a lot better than print statements, where it tells us, okay, advanced, this is the name of the file, right? Then we have debug, info, warning, whatever, and we get all of the information. And then if we go here, let me just go, you'll see we have this app.log, and we're able to get a log to the things that we put inside of the file. Okay, hopefully that makes sense, but that was kind of what I was trying to show you there, is that you can set up multiple different loggers. In this case, we can have one that goes to a file, we can have one that goes to a console, we can set up the formatter, and we can just be a lot more detailed, and we can actually save the information, which is quite important, especially in a production environment. Now, the next anti-pattern on my list is one that everyone is going to use at some point, and typically for good reasons, but that is to ignore the standard library. Now, a lot of people don't actually know all of the features that Python has, and they end up writing a bunch of code that's already built into the language. And while it's fine, it's not really a big deal. Obviously, if you know about these features, you can use them, you can have more efficient code, and you can take advantage of these built-in libraries that, you should prefer to use if possible. So I'm going to give you a few examples here. You can see here that maybe we're going to count all of the items in a list, and we want to see like the frequency of those items. There's nothing wrong with this code, but Python actually has a built-in counter module that comes from the standard library from collections, which you can use, which will do it for you, which I'll show you in a second. Now, with this function, we could use it to, for example, find the most common item. And to do that, we kind of write this complex sort where we're using this lambda key, and we're checking like all of these different values and seeing if it exists. And again, nothing wrong with that code, but it's just not the most optimal way to do this. Same thing, very commonly, people manually try to create their own file paths. Again, you can do that, but there is built-in modules that help you do that. Even same thing, checking if a file exists. We can use the OS module to do this, but there's also a pathlib module, which is designed specifically for dealing with paths. So I'm just going to show you those examples now. You can see like this is our exact replication of this function right here, where this will create a dictionary for us that contains the frequencies of all of the items. Then we can use the counter to find the most common item. So you can see that we're able to get that. And then, if it doesn't exist, we can return none. Same thing for building a file path. We can just put a path around the directory, and then we can add various directories to it like this. We can check if a file exists by simply wrapping it in path and going path.exists and path.isFile. Same thing for getting the suffix of a path. We can just directly use it from the pathlib module. Now, by no means am I saying you need to memorize the entire Python standard library, but especially if you're dealing with things like paths or files or things like collections, so you're dealing with like a counter, Python has a lot of those features that are pretty well known. So if possible, just use them. It will save you a lot of time and you will just have better code. Now, the last pattern on my list, in my opinion, is probably the most infamous one in Python. And that is because so many people don't know that this is an anti-pattern, and it can really catch them off guard and lead to some really tricky bugs that are hard to find or hard to solve. Now, that is by using a mutable default parameter or mutable default argument. Now, essentially what that means is that when you have a default, I call it default parameter, some people call it default argument in the function, and you have something that is mutable assigned to that. Now, something that is mutable would be like a set, a dictionary, a list, any Python object, essentially something that's not a like none type or int or what do you call it, string or tuple or boolean or float. If it's not one of those values, then it's most likely mutable, and that means it can change. Now, the reason why this is very bad, having this example here, is because it doesn't work like you would expect it to work. If you modify this parameter right here from inside of the function, it actually changes the value of the default that will be used on a subsequent function call. Now, without getting into a ton of examples here, let's imagine that we call this function, right? And we say, add underscore item underscore bad, and we pass an apple, right? So it's actually just generating the example for me because AI is like this. You would expect that, okay, it will just create, a new list. It will just add this item to the list, and we'll just get back a list with one item every single time. That's actually not the case. You'll see that if we run the print statements down here, I'm not going to run it, but this is exactly what will happen. First, we'll get a list with an apple. Then on the second call, even though we're not referencing the list with the apple at all, we're going to get apple and banana in the list. And that's because as soon as we called this the first time with apple, you can imagine that it kind of just gets inserted inside of this list because the default value itself has changed. It's kind of the same thing as if I did like, new items is equal to this, and then I made this equal to new items, right? And then you can say, I'm saying items.append item, but items is just new items, which is this list. So this list just keeps getting larger and larger and larger, and is still being treated as the default value here in this parameter. So you want to not do that, and I'm going to show you how to avoid that in 1 second. Let's just get rid of these examples and go back to our AI generated code. Okay, now same thing applies here, right? We're using a default value, most commonly used with a list, but also could be used with a dictionary, and it's going to cause these same errors, even if it's inside of something like an initialization in a class. Okay, so let's scroll down and see an example of how you should do this. If you do want to have, for example, a default value be a list or be a dictionary or be something mutable, you should simply assign it to none. You should then check if the thing is none. And if it is, you can just initialize the value equal to a list. Because this is done inside of the body of the function, this will be a new list every single time, and you won't get the same error that you got before. So you can see in all of these examples, we simply make the default value equal to none. Then we check if it's none. If it is, we can initialize it to what we want the value to be. And that saves us and avoids us from having that really annoying bug, as you can see down here. Anyways, that's all I had to show you guys here. Those are the 7 Python anti-patterns. Let me know which one surprised you the most in the comments down below, and I will see you in another video.